on our notes. So first of all, three little things that we're not doing at the moment, we're going to leaving until after electricity or during electricity. So the bottom of page 1, charge particle electric field, charge particle magnetic field, we're waiting until we do electromagnetism. Makes sense, okay? If you follow through to page 5, we're leaving this experiment as well because it deals with what's called the inverse square law, and we'll be dealing with the inverse square law when we're doing Coulomb's law in electricity later on, and then we'll come back and have a quick look at this. Okay, so they are the only bits we have left. They're all minor parts of the atom. I wouldn't worry about it. I still consider the atom is done when we've what we've done. Okay, let's move on to page 9. Okay, diagram of a tube, so let's have a quick look above here again. Okay, so we have a gas inside the tube, we have a metal tube, we have a wire electrode, negative supply, power supply. So the metal tube, write down that as the cathode, and the wire electrode is the anode. Okay, so radiation enters through the mica window, radiation ionizes the gas, negative ions are accelerated to wire anode, where the strong electric field causes ions to accelerate more and more. Okay, negative ions. Now instead of negative ions there, will you just put in the electrons? Okay, because the negative ions are effectively electrons. Okay, so, and we'll change that to electrons there as well. Okay, pulsar current is obtained in the external circuit which can be amplified. Okay, so we have an external circuit here, so we'll just draw that in. Negative supply, positive supply, and put in here, as we did a minute ago, the rate meter. Okay, everybody happy enough? So that's the diagram tube, and the rest of that page is sorted. Okay, we're sorted on the rest of that page. Right, that's page 9. If we move back then 2 pages to page 7, quick look at emission of line and continuous spectra. So set up the apparatus as shown. Okay, right. So we have a gas discharge tube. Okay, in this case it's containing hydrogen, and we'll just say R helium. Okay, R sodium, vapor. Okay, now we send that through a prism or a diffraction grating. Does the same job. And on a screen, we get a spectrum on the screen. Okay, now we get a line spectrum as shown here. Okay, for hydrogen. So look, you get these colors, these special colors, and look, they even have the exact wavelength. Okay, so that's the fingerprint for hydrogen. Different fingerprint for sodium and so on. If you replace the hydrogen lamp with a filament bulb is just a metal, much more complicated, and instead of just getting the 4 or 5 lines, you get every line. You don't see them as lines, you just see the full spectrum, the rainbow. Okay, and a continuous spectrum. That's it. Okay, uses. Okay, spectroscopy. Each element is a different line spectrum. Light from the vapor element can be used to identify the element.